Alright, so the second part of this problem, we've already solved for the coefficient of friction b equaling to tangent theta. Now I've got to determine how long, or how much distance if you will, is going to be required to bring that penguin to a stop. Okay? Now, what we're going to start off with is my free body diagram. I already have my normal, my weight, and my force of friction already listed on my diagram. I did that in the previous video. Now I'm going to use that to solve for the acceleration. Okay? So first things first, we know that the force of friction is the only force in the x direction. Okay? We also know in the y direction we have the normal minus the weight. Excuse me. This is in the y direction. Now there's no acceleration in this direction, but there's clearly, because there's only one force here, there's clearly an acceleration in the x. So this is going to be equal to 0, and this is going to be equal to ma. Okay? Cool? So now, plugging in for what I have, well, I know that the force of friction is going to equal to the coefficient times the normal. Okay? And I can use this to say that the normal is equal to the weight. Okay? So doing a substitution, I end up with mu k times mg equals ma. Now, really quick, most one-body situations, the masses cancel out. They don't contribute for one body. Okay? So, bang, mu k times j. Now, how does that help me? Well, I know the original velocity. I think it was 1.4, but I'm not sure. I have my initial velocity. I have my acceleration. And if I want to solve for the amount of time it takes for it to stop, I know my final is equal to 0. Okay? So using my old kinematics equation, V final equals V initial plus my acceleration times time. We're going to use that to solve for time. Erase this real quick. Okay? Alright, so V final is 0. V initial, I do believe it's 1.4, but I could be wrong. It's 1.4 meters per second. Plus my acceleration, which turned out to be the coefficient of friction, times g times t. Now we did say that the equation of theta, okay? So I can go back and make that substitution.
0 is equal to 1.44 meters per second plus tan theta times acceleration gravity times t. Move this term over there, but this term I end up with t. That is my answer. Okay. If I need to solve the distance at this point, I do now have t. So for t, I can go back to x equals x naught plus v naught t plus 1/2 squared and solve my distance. Okay? I can also use the old time independent equation, v final squared minus v initial squared, and v final and v initial is equal to 2 times the change in my distance, which I don't know, which should be a total stopping distance, times the acceleration, which is tangent theta. Okay? So that's how you solve that